Let's explore functions obtained from a sequence of transformations. So we'll start with the graph of the function that is defined by the formula the square root of x. And to that graph, we will apply the following three transformations in the order listed. So we'll end up with a graph. It'll be the graph of a function, and this function is defined by what formula? That's what we have to figure out. So we're starting with the graph of the function defined by the formula the square root of x. And we want to shift that graph down 9 units. So shifting down 9 units means that if you take your original formula, you then graph the function defined by the formula f of x minus 9. So after this first step, we're graphing the function defined by the formula the square root of x minus 9. Okay? And then we're going to take that formula, look at its graph, and reflect that graph about the y-axis. So now reflecting about the y-axis means if you take the formula you're starting with, you then graph the function defined by the formula f of minus x. So here I take the formula, replace x by minus x, and we get that. So now we want to take the function defined by this formula, graph it, and shift that graph down 2 units. Shift it left 2 units, excuse me. So shifting left 2 units, it's what happens. You take the original formula, f of x, and then graph f of x plus 2, like that. So we replace x by x plus 2. That is incorrect. Use the parentheses. We're replacing x. Wherever I see an x, replacing it with x plus 2. So this is right. And this is written as the square root of minus x minus 2, and then minus 9 on the outside. So in the end, we have the graph of the function defined by this formula. Let's take a look at the function defined by the formula minus 3 times the cube of x plus 5. Let's sketch a graph of y equals f of x by hand. So take a look at this formula. Among all the functions defined by those basic formulas, this one is naturally modeled upon x cubed. So we can arrive at our function by taking the function defined by the formula x cubed and applying a sequence of transformations to it. So when doing this type of problem, I recommend first trying to use the following order. First, do any and all reflections. Second, stretches, compressions, and then shifts. Usually, when you apply this order, you will be successful in a very easy way. You might also want to consider using this ordering, where we just interchange shifts and reflections. So you start with shifts, and then at the very end you do any and all reflections. Let's try to apply this first order. Let's see, are there any reflections? To start with x cubed and arrive at the formula for f, we do make a reflection because I see a minus sign in front of the whole formula. So let's go to the formula minus x cubed. So this is, let me not use the letter f again. Let me use the letter g. So it's like starting with the formula g of x, and then you're looking at the formula minus g of x. This is a reflection about the x-axis in terms of the graphs. Let's see that. We start with this graph, and let me label these 3 points. And then for the new graph here, just a reflection about the x-axis. And these 3 points correspond to these 3 points here. This is the point 1 comma minus 1, and this is the point negative 1 comma positive 1. So now there are no more reflections. There's not a minus sign in front of x in the formula for f. There's no reflection about the y-axis that we should do. And we see that there is a stretch. Right? We have minus 3 in front in the formula for f. So let's look at minus 3x cubed, which is 3 times minus x cubed. So if you're starting with the formula g of x, you're then going to the formula 3 times g of x. So this is a vertical stretch. The graph gets taller. So here are the points in the new graph corresponding to the old points. For this point 1 comma minus 1, I take the same x, 1, and now I look at the y of minus 3. Multiply the y coordinate by 3. And one more. We have x plus 5 in the formula for f. So I will take this formula, and I will replace x by x plus 5. So this is a horizontal shift, left 5 units. And now we've arrived at the formula for f. So here is the graph of f. What do these 3 points, the previous graph, correspond to down here in the last graph? Well, I'm going to take the x coordinate and I'm going to subtract 5 from it. So now I get minus 6 comma 3. I get minus 5 comma 0. And I get minus 4 comma minus 3. Here's what the graph looks like. Goes to those 3 points. Here's a better picture of it.